Write your name and roll number in the chat box. We will wait for 1 minute. Then we will start. Yes, we will start now. I want to give information about one test. On next Saturday, we will conduct online test of 25 marks on the chapter halogen derivatives. So what we have to do the preparation of this chapter. I will send you one Google link at the lecture timing, and the Google link will be automatically, it will be end, your test will be automatically end within that prescribed time. I will give 40 minutes of timing. Within that 40 minutes of time, we have to finish your test. After finishing the test, immediately we will get your marks also, and we will get the certificate if you qualified the exam. If you didn't qualify, again we have to apply for the exam. But for the reapplying of the exam, we have to take the permission. I will send again the new link. So I am thinking about such type of test on the next Saturday. So I think next Saturday, it is 8th of August. So on 8th of August, we will conduct one test. So I will prepare the question paper. Online test will be online. You will get the Google link. You have to write the questions. It will be totally MCQ type of questions will be there. And after finishing, we will get the results also. So I am coming back to the nanochemistry and green chemistry. In the previous lecture already, I think this is completed. This is also completed, number 7. Number 8 is also completed. Yes, use of catalysis. We are discussing about this use of catalysis. This is number 9 principle of green chemistry. So what is happening in case of green chemistry if the catalysts are used? See, if the catalysts are used in the chemical reaction, the main role of the catalyst is to increase the rate of reaction. So energy efficiency will be uh, more. Catalyst helps to increase the selectivity. Means for the specific group conversion, specific catalyst is used. Now, you know, in organic chemistry, we already studied about the many catalyst, catalytic hydrogenation reaction, you know, H2, platinum and palladium, ranny nickel, it is used as a catalyst. In many Ziegler-Natta catalyst also, you know, this is used for the uh, preparation of high density polythene. In the chapter number 15 already we discussed about this. So catalyst is used for the selective reactions, is also minimize the waste also, then also reduce the reaction time and energy also. Then design for degradation. This is the number 10 principle of green chemistry, design for degradation. So we have to design the chemicals that will be automatically degrade. Automatically degrade means they will be degrade by the microorganisms in the environment and can be discarded easily. Means the chemicals or the waste product should be degraded easily or discarded easily. Uh, so their degradation products are not toxic. The degradation, if the degradation products are hazardous or these are toxic, they will causes the environmental pollution. So we have to design such type of chemicals that chemicals should be easily degrade by the microorganisms. Also, they should not be toxic. They should be bioaccumulative, means easily accepted by the biodiversity, and environmentally persistent, means if they remains in the environment, they do not causes any effect to the environment. So such type of designs are required. See here, one example I will give here. Waste product should be degraded automatically. I explained in earlier this one. Waste product, whatever the waste products which are eliminated from the reactions, these will be easily degraded and automatically degraded to clean the environment. Thus, the biodegradable polymers and pesticides are always preferred. Nowadays, due to this use of green chemistry, biodegradable polymers and pesticides are used nowadays. Uh, Now we are using the green chemistry approach to make the separation easier for the consumer. This is very important. This is newly added in your textbook also. To make the separation easier for the consumer, an international plastic recycle mark is printed on the larger items. This practical activity is also included in your practical book. You have to purchase the practical book also. So this is a international plastic recycle mark. I will explain what is this international recycle plastic mark. So I will explain one by one. This is one activity is also included in your practical. Means what we have to do, we have to, in our day-to-day life, we are using many things. Mobile covers also, then the plastic containers, then mineral water bottle, shampoo bottles, then food grain containers, then baby feeding bottle, then plastic wrappers, shampoo bottles, PVC pipes, then what we can see. Steam machine plastic. So these are the number 1, 2, 3, 4, 5, 6, 7. These are the recycle marks universally accepted. These are also called as the resin identification codes, RIC codes. Purposefully this is included in your syllabus because we have to check this mark. These are the 3 arrows. All these 7 RIC codes. These are also called as RIC codes. RIC indicates the resin identification code. And this is also called as plastic identification code. Means the plastic material or whatever the material which is made up of with, which material it is included in this one. So this one indicates what? If the any material which is printed with such type of arrows, these three arrows indicates this material is recyclable, means we can recycle it. And this one indicate what? This one indicate it is made up of with PET. PET, we know this is polyethylene terephthalate, or it is also called as PET. So we have to check these marks in your household materials. It is printed anywhere. It is printed below the bottles, or it is printed on the side of the bottles. So the where it is used, this mark, number one, it is used in microwavable food trays. So in your home, if the microwavable food trays are there, so below these trays, this will be printed. This mark will be printed, and this one indicates it is made up of with polyethylene terephthalate. It is also used for salad dressing, soft drink bottles, then water and beer bottles. So all this is a recyclable material. And what is the status of this? It is very hard to clean, means if such type of bottles are there or such type of material is there, it is very hard to clean. It absorbs the bacteria and different flavors. So avoid reusing. Don't use these bottles. That's why instruction is there on the mineral bottles. After using, crush the bottles. So don't use these bottles, because uh, the conditions are given here. These are very hard to clean, absorb the bacteria and flavors. So avoid reusing. So if these bottles are recycled, which material is prepared? See, if these polyethylene terephthalate bottles are recycled, these are used for preparation of carpets, then furniture, new containers. Again, new bottles will be prepared. And the polar fleece. This polar fleece is a one type of fiber material. It is very soft. So it is also prepared by using this polyethylene terephthalate. Then I am coming to this number 2. This number 2 mark is HDPE. Wherever you find such type of mark and number 2 is written, means it is made up of with high density polythene, remember. So it is found, this mark is found on household cleaner and shampoo bottles. So at our home, if the shampoo bottle is there, we have to check such type of mark is there. So such type of number 2 indicates it is made up of with high density polythene, HDPE. And what is the status of it? It transmits no known materials into food. So we can use it. And if it is recycled, it is used to make the detergent bottles, then fencings, floor tiles, and pens. So after recycling, such materials are prepared. Then I'm coming to the number 3. Now you understand such type of marks we have to check in on every plastic material. Number 3 indicates it is a V or PVC. Below this mark 3, V is printed or PVC will be printed, or only 3 will be printed. So this 3 indicates it is made up of with polyvinyl chloride. It is used in cooking oil bottles. See, all the cooking oil contains such type of mark. Then clear food packaging, clear, which is transparent, which is having such type of mark. Then mouthwash bottles. We have to check all these marks, because this activity is there for the practical. And if you make a list of this separately on PVC pipes, we are finding this type of mark. So the activity will be automatically completed at your home. And this activity we have to write in your practical cum journal, which is available in the market. So depend upon this, one activity will be completed, and side by side I will explain all the activities. So I request all of you, now the practical cum journal notebooks are available in the market. uh, so ask your parents to purchase this, or tell your parents to purchase practical cum handbook. I think the price is 77 rupees. Yes, just I will check the price. Yes, practical handbook cum journal having the price is, yes, 77 rupees. And this activity this activity is included. I want to tell the name of the activity. Just wait. Yes, number 5. Fifth activity is given in your practical cum journal book. So this activity will be automatically completed after teaching this part. And what is this activity? Just I will read the aim. Identify the RIC code or recycle symbols on of plastic on different plastic materials. And different plastic materials we have to use a mineral water bottle, then your mobile phone transparent plastic black cover. If it is available, then you can check. If it is not available, you can use the different plastic material. Then PVC pipes, if it is available in your home, you can check the PVC pipe, which type of material, which type of mark is there. Then plastic beaker. Plastic beaker is not available at your home, I know, because this is available in the laboratory. That's why it is included. Then number 5, baby's feeding bottle. If the baby's feeding bottle is available in your home, then you can check. Otherwise, you can use the any 5 materials we have to identify. We have to check the any 5 materials. Then soft drink bottle. Mineral water bottle is different. Soft drink bottle is different. Then plastic containers, oven trays, shampoo bottles, then shampoo pouch. So we have to just observe these marks and we have to complete this activity which is included in your textbook. Now I am coming to the number 3 where it is used, cooking oil bottles, clear food packaging. What is the status of it? It is believed to contain the phthalates that interfere with the hormonal development. So avoid reuse this. So this status indicates this is uh, causes hormonal development, interfere with hormonal development. So avoid these reuse of these such type of bottles. Then I'm coming to the, and where it is recycled, it is recycled to prepare the cables, then mud flaps, then it is used in paneling, roadways, gutters. Now I'm coming to number 4 mark. It is a plastic recycle mark. Number 4 indicates LDPE. It is printed. LDPE is low density polythene. It is clear cut mentioned there. If it is not mentioned, this 4 indicates LDPE. Means we have to remember what is this one. One is polyethylene terephthalate. Number 2 is high density polythene. Number 3 is polyvinyl chloride. Number 4 is low density polythene. Number 5 is polypropylene. PP means polypropylene. Number 6 is polystyrene because PS is written, it is polystyrene. And number 7 means other than this. If the number 7 is printed, it will be other than this. So I'm coming to this LDPE. LDPE, it is this mark is used on bread and shopping bags. So if you bring the bread at your home, you have to check such type of mark is there or not. Bread and shopping bags, different shopping bags on this mark is there. I think transparent, which are transparent on which this is printed. Means in the grocery shop, whatever the plastic bags are used, this mark is already printed on it. Then it is also on carpet, clothing, different furniture, packings. So it transmit no known chemicals into food. Means what type of chemicals, no known chemicals into food. So you can use this again. We can use this again, so it is not dangerous. And these are recycled to make envelopes for floor tiles, then trash can liners. This is used for recycling. Then I'm coming to the polypropylene. This polypropylene mark we can found on the ketchup bottles, medicine, then syrup bottles, whatever the bottles which are made up of with this plastic, then drinking straws. And what is the status of these transfits? No known chemical materials into food. So also these can be reused. And if these are recycled to make the battery cables, brooms, see, all the brooms are prepared by using this when this is recycled. Then ice scrapers, rakes, this is used. Then I am coming to this polystyrene. Only where it is used, this is important. This status and this where it is recycled, this is not used. This will be not asked for exam. But where this is used, it will be asked for 1 mark. And this mark will be asked for 1 mark, remember. 1 indicates what, this 2 indicates what, 3 indicates what. So don't go in detail. This will be not asked for exam. This status and where it is recycled, this will be not asked. But this 1 indicates what, it will be 100% asked for exam, and where it is used. So please concentrate on it. Polystyrene, this is used, this mark we will find on disposable cups and plates, egg, carrots, then whatever the containers we can use in refrigerator also. Then I'm coming to this number 7. Number 7 is miscellaneous. Means it is not particular. Used in 3 and 5 gallons water jugs, then nylons, some of the food containers it is used. So it is your homework today. We have to check such type of marks, and we have to complete the activities at your notebook, and then whenever you bring the practical book, complete this activity. So next one is real-time analysis pollution prevention. This is a number 11 principle of green chemistry. Real-time analysis means continuously we have to monitor the reactions, and nowadays this is required. Analytical methods need to be developed which are continuously monitored. Yes. So directly I am coming to the example. Analytical method should be developed or modified. Whatever the analytical methods you are using, it should be modified so that continuous monitoring of the manufacturing and process units is possible. Nowadays, in many chemical industries, we found this real-time analysis means this is very much important for the chemical industries and nuclear reactors. How much waste product is generated and waste is started, we will continuously monitor. So this is expected real-time analysis. Then last one is last green chemistry principle is safer chemistry for accident prevention. Nowadays it is very important. We have to use the safer chemicals because in chemical industries many explosions and hazards are occurring. So we have to use such type of chemicals which should minimize the accidents. We need to develop chemical processes that are safer and minimize the risk of accidents. Always the gaseous substances, if this is used, there is a more danger of the explosion. So we have to avoid these gaseous substances. Safer chemicals means we can use the non-volatile liquids or solid substances. These are very safe. So it is clear-cut mentioned in the example. Safer chemicals should be used to minimize or prevention of accidents and explosion. If the chemical process is carried out with the gaseous substances, if the gaseous substances are used, there is a possibility of accident, more possibility of accident than the non-volatile liquids and solid substances. Volatile liquids are also dangerous, like benzene is dangerous, carbon tetrachloride is dangerous, then ether is also dangerous. They can, these are volatile, so they easily catches fire and the accident can take place. So we have to avoid such type of chemicals, and we have to use non-volatile liquids and solid substances. So the main purpose of all these 12 the principles of green chemistry is to minimize the pollution and energy crisis. So what is this role of green chemistry? So it is a role of green chemistry means already I have explained all these things. Once again, I will explain in brief. So what is the role? First one, to promote innovative chemical technologies. We can write in your own words if this is asked for exam, and this will be asked for 2 marks. What is explain the role of green chemistry in your own words, you can write down. So to promote the innovative chemical technologies that will reduce or eliminate the use of generation of hazardous substances. And in your own words, you can write down this one. I am not explaining in detail. So green chemistry also helps to reduce the capital expenditure to prevent the pollution. It incorporates the pollution prevention practices. Then whatever the 12 principles are already learned, we can mention all the principles here. Then number 3 is green chemistry is a new way of looking at the chemicals, safer chemicals. The manufacturing process should be designed in such a way that they will minimize the increase the atom economy. Then they will minimize the waste production. So this is a very easy to write down. This is a theoretical question. Green chemistry helps to protect the presence of ozone in the stratosphere, essential for the survival of life. This is like 9 and 10 standard question. Green chemistry is also useful for controlling the greenhouse effect. So I'm not paying very much time on it. Now this is a nanochemistry, introduction to the nanochemistry. What is meant by nanochemistry? Before nanochemistry, you should understand what is meant by nanoscience. So nanoscience is a science in which it is the study of phenomenon and manipulation. See, manipulation means it is the changing of materials, manipulation of materials at atomic, molecular and macromolecular scales, where the properties are differ significantly from those at a larger scale. Means what is meant by nanochemistry in one sentence I will explain. It is nothing but it is the study of phenomenon and manipulation. Manipulation means we have to change of materials at different sizes. See here, atomic size is different, molecular size is different, then macromolecular size is different. So at all these scales, the properties of the materials are different. The properties differ significantly from those at larger scale. So this is called as a nanoscience. Nanotechnology means what? It is a technology and it is a science. Nanotechnology means this is all these definitions will be asked for 1 mark. So that's why I have given these definitions. Nanotechnology means what? See, it is the design first. We have to design. Nanotechnology means it is the design. Number 2 is characterization. Number 3 is production. And number 4 is application. So it is the design, characterization, production, and applications. Kiska applications of structures, device, and systems. Means there are 4 things. It is the design, characterization, production, and application of structures, device, and system by controlling its shape and size at nanometer scale. Now, what is this nanometer scale? I am coming to this nanometer scale. So this nanometer scale, nano is a Greek word which means dwarf. But in actual case, nano is smaller than dwarf. Nanoscale is defined as 1 to 10 nanometer is equal to 1 nanometer is equal to 10 raised to minus 9 meter. So remember this nanometer scale. This will be asked for 1 mark for the board exam. What is mean by nanometer scale? So nanometer scale is 1 to 100 nanometer, and 1 nanometer is equal to 10 raised to 9 meters. Now I will explain what is mean by bulk material and what is mean by nanomaterial. So bulk material, you are well familiar with this bulk material. The materials we see around us, all these are bulk materials. Bulk materials means these having the macroscopic physical properties. Macro means these are very large physical properties. For example, is given here, grain of sand. Grain of sand that is a micron size and possesses the same bulk properties. So if the material is a micron size, these are the they having the properties of the bulk materials. Means whatever the properties of bulk, this micron size material also having the properties of bulk. But see what is mean by nanoscale material or nanomaterial. But the material synthesized as nanoscale means if any material which is synthesized at this 1 nanometer to 100 nanometer, it is having the unique optical, structural, thermal, catalytic, magnetic, and electrical properties. This is a difference, main difference between the bulk material and nanomaterial. In case of bulk material, all the particles having the properties of the bulk. But in case of this nanomaterial, nanomaterial means which is at this nanoscale, 1 nanometer to 100 nanometer, whatever the material which is at nanoscale, which possess the unique properties. Unique means these are that particular material only having this property. That is well, that's why it is called as unique properties. Unique, which properties? Optical properties are unique, also structural properties are unique, then thermal properties, then the catalytic properties, then the magnetic properties, the electrical properties. All these properties are unique. So these properties can be changed as a function of size. Means size will be changed, these properties will be changed, remember. And are very different from their bulk materials. Means bulk material properties are different and nanomaterial properties are different, remember. And these properties are unique properties. So what is mean by nanomaterial? The material which is prepared at this 1 to 100 nanometer scale, it is called as nanomaterial. Then means one dimension. It is the material having the structural components with at least one dimension in the nanometer scale. Means the material which is prepared, which is having at least one dimension, should be at nanometer scale. Nanometer scale already I explained, 1 to 100 nanometer, and 1 nanometer is equal to 10 raised to minus 9 meters. So these nanomaterials means what? These nanomaterials are larger than single atom. Means whatever the size of the atom, these nanomaterials are larger, but the smaller than the bacteria and cells. One diagram is shown in your textbook, but I have not taken this diagram. This will be not asked for exam, but we have to remember what is meant by nanomaterials. Nanomaterials are larger than single atom, but smaller than the bacteria and cells. Nanomaterials, it may be nanoparticles, dot particles are there, then nano wires will be there, nanotubes are there, according to their dimensions. Dimensions are changed, then this wires, nanotubes and particles will be changed. So directly I am coming to this nanochemistry. What is mean by this nanochemistry? Nanochemistry is nothing but preparation of the nanomaterial. It is the combination of chemistry and nanoscience. See, nanochemistry deals with the designing and synthesis of nanomaterials. See, nanochemistry is nothing but it deals with the designing first. We have to design. Synthesis means preparation of materials at nanoscale with different size, shape, structure, composition, and their organization into the functional architectures. So nanochemistry is, it is nothing but the preparation of designing and preparation of nanomaterials in simple words. So application of nanochemistry in medicine, see, this is a very good example. All of you or some of the pupils are using the sunscreen lotion. A sunscreen lotion contains the nanoparticles of zinc oxide and titanium dioxide. If you see the contents on this sunscreen lotion bottle or sunscreen lotion tube, it is clearly written, it contains zinc oxide and titanium dioxide. These are the nanoparticles. These chemicals protect the skin against harmful UV rays by absorbing or reflecting the light and prevent the skin from damage. So this is one application which is used in medicines, and these nanomaterials. See, this is a zinc oxide and titanium dioxide. This can be used for your board exam. Sunscreen lotion contains which of the following nanomaterials? So remember this, zinc oxide and titanium dioxide. Then what is the dimensions? So 0 dimension, 1 dimension, and 2-dimensional nanochemical systems. I will explain one by one. 0-dimensional nanostructures means, see, for 0-dimensional nanoscale nanostructures is one in which all 3 dimensions are in the nanoscale. Means all the 3 dimensions are in the nanoscale. For example, nanoparticles, if the nanoparticle is there, it is included in 0-dimension nanoscale structure. Then nanoshells, nanorings, all these are the examples of 0-dimensional nanostructure. Then 1-dimensional nanostructure means what? See, in which two dimensions are in the nanoscale structures. One dimensional nanostructure means in which the two dimensions are in the nanoscale. And a zero dimensional nanoscale structures means all the three dimensions are in the nanoscale. One dimensional nanoscale structure means, yes, Soham Ambede, put off your video. Yes, then next one, see the examples of one-dimensional nanoscale structures, nanowires, nanorods, nanotubes, then nanofibers. All these are the examples of one-dimensional nanostructures. Now, I'm coming to the two-dimensional nanostructures. Two-dimensional nanostructures in which one dimension is in the nanoscale. See, don't make confusion between two-dimensional, one-dimensional, and zero-dimensional structures. Zero-dimensional structures, because here is written zero-dimensional and all the three dimensions are in nanoscale. Here is written one-dimensional nanoscale structures. One-dimensional nanoscale structure means two dimensions are in nanoscale. Two-dimensional nanoscale structure matlab one dimension at least is in nanoscale. So thin films, layers, and coating. I will give this example. So see this example. The dot is written. These are the nanoparticles. These are the nanotubes. Yellow colored we can see clearly here. So this is a yellow colored mark. This is a two-dimensional nanoscale structure. Then this is a one-dimensional nanoscale structure. Thin films, layers, and coatings. See, this is a two-dimensional nanoscale structure, thin films, layers, and coatings. So we can realize with this example, this will be not asked for exam, but the definition will be asked for exams. So don't pay attention to these diagrams. This diagram is only shown for your understanding purpose. What is meant by nanoparticles? These are the dots are nanoparticles. Then these are the nanotubes or fibers. And this is a thin films, layers, or coatings. The next part is characteristic features of nanoparticles. These nanoparticles having the specific features. Number one is color. So when this good example is given, there are three bottles A, B, C. These are the gold particles. So color, it is an optical property that is different at nanoscale. See, the color is optical property that is different at nanoscale. The elemental gold has a nice shining yellow color. When the gold is present in elemental state, it is having the, all of you seen the gold, it is originally yellow colored. But if you had only 100 gold atoms, see, these are the nanoparticles, 100 gold atoms. When these are arranged in a cube, its color would be much more red. See this bottle number C. See, this is elemental, then the particles are increasing. When the 100 particles, gold atoms are there, its color becomes red. So this diagram, this picture is shown for your understanding purpose. Only 1 minute remaining, so I will take another one example. And we will stop here. Tomorrow's lecture, I will explain the remaining part. So surface area, remember, increase in surface area with the decreasing particle size. In case of these nanoparticles, if the size will be decreasing, then the increasing surface area will be more. Then I am coming to the catalytic activity. Heterogeneous catalysis, you know, due to increase in surface area with the decrease in particle size, means the nanoparticles which are having the good catalytic activity, because the particle size is lower. If the particle size is very small, then the surface area is more. So this catalytic activity used for the heterogeneous catalysis means usually